The sciences have a lot of the hugeness of room essentially prepared to be handled in one of the universe's most. It was revealed in 2017 to confound mysteries. Oumuamua, when stargazers at Hawaii's Halaka Observatory saw this as puzzling interstellar article, it enchanted the thought of people all over the planet. Trained professionals were confused by its bizarre design also. Its rising course, it broke each rule, not the slightest bit like that had at any point been seen by us before. Was just a comet, a space rock, or maybe something absolutely special. At any rate, right when we acknowledged the story was over, words pour out of NASA passageways with regard to Oumuamua's undeniable return. However, how does this influence mankind? Is it an indication of approaching fiasco? And heavenly messenger bearing terrible news? Oblige us as we explore how NASA specialists alert Oumuamua is returning to Earth, and the consequences of its moving toward return. The essential interstellar thing to go through our planetary gathering was spotted by cosmologists using the Pan-STAR study on October 19, 2017. The article, which has the task 1I-27 Oumuamua, began warm conversation among analysts and continues to do as such straight up till now. How this item was recognized showed that interstellar articles frequently enter our planetary gathering, which was something everyone could choose, and as time has slipped by, scientists have seen that as rarely a piece of these things hit Earth as meteorites. This inquires the imperative request: have extraterrestrial bodies been visiting Earth for billions of years? Given that this is valid, might they at any point have conveyed the significant parts for life? Panspermia is the hypothesis that the universe is arranged with life and spreads by implies of space rocks, comets, and other wonderful bodies. In another report, a social event of scholastics examined the results of interstellar things being the justification for panspermia. Their disclosures proposed that interstellar peril could have the choice to give the material to thousands if not billions of Earth-like planets to outline in different bits of our universe. Jr. David Cow of Thomas Jefferson Optional School for Science and Development was answerable for the get-together. Fundamentally, panspermia is the conviction that extraterrestrial articles convey life to Earth. Speculatively, these extraterrestrial animals created into extremophile microorganisms that could persist through the over-the-top state of room because of the framework space shakes, make their way through the interstellar medium and eventually impact planets that could maintain life. This perceives panspermia out and out from other rival speculations of Earth starting points generally considered abiogenesis, the most well-known of which is the RNA world theory. In this speculation, RNA created before DNA and proteins, which in this way provoked the advancement of local life in the world. At any rate, Cow battles that panspermia is positively not a straightforward eccentricity. To evaluate panspermia is hard to survey since it incorporates such countless variables, an enormous number of which are dark or have no necessities. For example, we truly care about to think about the regular viewpoints. Can extremales persevere through infinite blast gamma radiation? The genuine pieces of panspermia, the quantity of articles that impacted Earth before the fundamental fossilized evidence of life, and so on. Also, there are at this point various unanswered or inadequately motable requests concerning these components. For instance, the quantity of extremophiles would truly show up at Earth in the event of a contact with an everyday presence-bearing thing, and what the likelihood is that life could start from these outcast extremophiles. Our appreciation of the believability of panspermia is reliably advancing on account of these also various purposes behind model the fluctuating star advancement rate and the new idea of various revolutionary free-floating planets. Transspermia is testing the gauge, being the first interstellar thing to be recognized. The 2017 revelation of Oumuamua meant a defining moment all through the whole presence of cosmology. Interstellar things apparently go through our planetary gathering from time to time, some of which are apparently still here, and that's what their ID showed. They were truly basic in the universe. A second interstellar item, 2I Borisov, entered our close-by planet bunch 2 years after the first, yet this time its propensity was not canvassed in secret. The comet 2I Borisov encouraged a story as it drew closer to Earth, avowing its character. Resulting assessment has shown that a piece of these things become meteorites that influence Earth's surface, and a couple have even been recognized by Cow. There are suggestions for panspermia, and the continuing with discussion on the beginning stages of life in the world. Expecting these extraterrestrials are for sure identify, we can duplicate the number, thickness and mass thickness of articles in the interstellar medium using real limits, especially its mass, size, round length. What's more, recommended interstellar medium number thickness. This makes it an exceptional piece of data for panspermia models. Using these models we can make sensible allowances about the mass, unendingly movement thickness of interstellar things, and we can use these assessments to by and large work out the all-out number of things that banged into Earth during the 0.8 long-haul time span the speculative window between when the planet formed. Furthermore, when life previously appeared on the planet, to choose the believability of panspermia, it is vital for know the all-out number of crash events on the planet during that 0.8 long-haul period, since a higher probability for panspermia would be deduced by a more noticeable number of crash events with interstellar things over that period. In short, the genuine properties of the interstellar Oumuamua. Consider the arrangement of mathematical models a characteristic model that gets a handle on the humblest item size, expected to protect extremophiles from astrophysical events like grandiose blast, gamma shaft burst, huge space rock impacts, passing stars. Thus forward was utilized by Cow and partners nearby mathematical models that record for the actual study of panspermia. Tremendous shafts weaken all interstellar articles beside the greatest previously. They show up at another system as shown by ebb and flow research. These worthwhile factors influence the likelihood of panspermia and the sum of perhaps influencing articles unsterilized by astrophysical sources that could hit Earth. In solicitation to deduce the base article size, we applied various models, for instance the circle squeezing methodology, to give a most realistic estimation of a goal distance to the nearest inestimable blast begetter using Orion, a fixed star, Pax as our model. The gamma radiation that shows up at that ejecta and the debilitating coefficient indicate how much radiation the ejecta ingests. In perspective, on the most conceivable compound union of ejecta water ice, the amount of ejecta that hit Earth previously, before life started, was surveyed by the gathering using their combined material science and normal models. The earliest fossils found in Western Australia date back to the Archean, which infers that life, as far as we may be concerned, began around that time, around 3.5 billion years ago. They contemplated that the best probability of panspermia beginning life on Earth is on the critical level of 0.01%. However, this probability appears low under the most confident conditions. Furthermore, we limited our survey to the beginning 8 billion years of Earth's set of encounters before the essential fossilized signs of life were found. It were found to happen on a deeper level. Considering that planets can be viable at any period of their lifetime and can continue to support life for up to 5 to 10 billion years, we extended our check for the total number of viable worlds in our system that are home to life by one critical degree. This Cow, furthermore, arrived at a final count of about 1, 0, 15, 10, 15 viable planets in our galaxy that could maintain life. At any rate, these counts are derived from the most confident figures of planetary reasonableness, suggesting that all rocky planets of Earth size within our habitable zones can maintain presence with thick conditions, appealing fields, and liquid water on their surfaces. All life-bearing ejecta that stored it into our environment can host organic entities. Based on what Cow said, their results do not show panspermia or put an end to the conversation about where life came from on Earth. However, they do set limits on the plausibility that objects like Oumuamua could have brought life here. Despite astrobiology becoming a totally different field, these results will undoubtedly have sweeping implications for cosmologists eager to get a clearer look at future guests due to Oumuamua's perplexing nature and the data interstellar things could propose about faraway star systems. There have been various thoughts for interceptor missions that could follow future interstellar objects, concentrating on them and even bringing back samples. For instance, the European Space Agency's Comet Interceptor, in a new commitment from the Southwest Research Institute, analyzed possible considerations and proposed an interstellar object exploration mission. Since Oumuamua's discovery, scientists have placed high importance on interstellar objects. We could acquire valuable information about the development of various stars and planets without actually sending missions there. If we could gather samples and analyze them closely, we could decipher planetesimal development models. Ground-based observations have been significant, and our understanding of small bodies in our nearby solar system has improved significantly through close encounters with these objects. Similarly, a nearby flyby of an interstellar object should be equally pivotal. It will be the next logical step toward exploring the early history of both our solar system and exoplanetary systems. Investigations of the quantity of interstellar objects have shown that around 7 pass through our solar system annually, while various assessments have indicated that some are sometimes captured and remain in our system. As advanced instruments become operational, specialists expect a substantial increase in the discovery rate of interstellar objects during the 2020s and 2030s. This includes the Vera C. Rubin Observatory in Chile, which is currently being built and is expected to collect its first light in January 2025. In its initial 10 years of operation, the observatory is projected to gather data on more than 5 million objects in the asteroid belt, 300,000 Jupiter Trojans, 100,000 near-Earth objects, and more than 40,000 objects in the Kuiper belt. During this study, Harsh and colleagues anticipated that any interstellar objects within a distance of twice the distance between Earth and the Sun would be sufficiently bright to be detectable by the survey. The proposed IE would have two main goals: first, to determine the composition of the interstellar object to provide insights into its formation and evolution; second, to study the characteristics of interstellar objects in our solar system in their early stages, yielding information similar to what the New Horizons mission discovered about the Kuiper Belt object Arrokoth, or what the ESA Rosetta mission found in Comet 67P/Churyumov-Gerasimenko. Understanding the activity of interstellar objects, particularly how they interact with solar radiation, is crucial. As these objects approach a star, ice sublimates, releasing dust grains and volatile organic compounds from their interiors. Previous insights have shown that comet activity is influenced by solar heating and the object's physical properties. By focusing on the visibility of an interstellar object and its spatial distribution, we can deepen our understanding of the fundamental processes that cause it to be active and how it formed. We can also delve deeper into the protoplanetary development environment where the object and similar planetesimals were formed, by examining the physical properties of the ices and gases. Refractories, on a superficial level, involve their substance, union, size, spread, and kind of mixing. Additionally, the transport setup is constrained by the transient properties of interstellar objects, as shown by Oumuamua and Borisov. These objects should go undetected until they approach the inner edge of the crucial space rock belt. Moreover, their exaggerated headings indicate that they will likely pass close to our Sun and become unavailable shortly after their acknowledgement. The block mission planning clearly impacts the spacecraft's ability to convey and reach the objective interstellar object, a Lagrange point at the Earth-Moon L1 point. This location was chosen by researchers for various reasons. One reason is that a spacecraft in such an orbit requires minimal thrust to achieve escape velocity. Most of its available speed increase is directed toward its cap, and this configuration dictates the amount of fuel required and the time expected to get going. It also permits a quick gravitational assist from a near-Earth flyby. Interstellar object studies are a young but rapidly developing area of cosmic investigation, integrating advanced observatories and proposed retrieval missions. Similar considerations have been advanced since the discovery of Oumuamua and Borisov, including Project Lyra, a drive by the Association for Interstellar Studies. However, such a mission is unlikely to arise for some time. Research like this will coordinate the next great step, which is the actual planning and testing of mission concepts. Further investigation is necessary before this can happen, but researchers emphasize that their work is a fundamental starting step. Now, imagine we track down an oncoming interstellar object that scientists initially categorize as a typical visitor, like Oumuamua or Comet Borisov. They might warm to the possibility of visitors from different parts of the universe, although none have been confirmed so far. But what if we find that this visitor isn't acting consistently? What if it moves in an unusual way or follows up purposefully? What if it sinks into a stable orbit? Consider the possibility that, upon further examination, we understand that a probe was deliberately sent to us. What if it can communicate with us? Humanity could find itself in a challenging situation, reminiscent of a sci-fi novel. How should we proceed? We don't know for certain if this will be our first contact, but it's possible that in a distant future, when we encounter one, we cannot dismiss this opportunity. Much thought has been devoted to the subject of how we should respond. Some have proposed bolstering our defensive capabilities, while others suggest formally establishing vital relations with extraterrestrial intelligence. John G.Z., who is not a working scientist, is the author of a new paper.